And so, okay, we're starting with part 4 now. And for part 4, or section 4 of the final project, we built a long short-term memory with time series data. Sorry, neural network with time series data. And so I used Amazon stock historical trading data that I got from Yahoo Finance for this. It is similar to the data we used in, I think, assignment 4 with, or maybe it was the midterm, with the Apple stock data. There was nothing in the assignment saying we couldn't use stock data for this. And so I didn't like how my neural network turned out for the Apple data. And so I figured that going with some data that is similar in structure would give me more time to actually, work on the design of the neural network and, mess with the parameters and stuff, instead of spend all my time making sure that, data is clean, or I'm doing what I'm supposed to be doing with the new data. And so I decided to focus on trying to improve the network rather than use a bunch more data. So the data runs from January 1st, 2014 to June 30th, 2019. I split the training and testing sets with testing at 10%, normalized and scaled it, set the length to, this is important, this is the length to 30 historical data points per. I changed it from our previous assignment. I thought that, the stock changes. I feel like the stock market depends a lot more on what's happened recently than long term. I don't know if that was the correct decision, and we'll see some points later discussing about whether I should change the length again. But I set it to 30, reduced it from 60 from the previous assignments. Batch size is set at 32. So I built a 6-layer long and short-term memory neural network. The first layer is an LSTM layer with 100 neurons. The second is a dropout layer with 20% dropout. The third is a LSTM layer with 100 neurons again. Fourth, 20% dropout. Fifth, 100 neuron LSTM. And then sixth, a 1 neuron dense fully connected layer. Activation was set to ReLU and return sequence is set to true. Return sequence means that this layer right here is going to pass into this, into this, and this, and this. This final layer right here was set to return sequence false. The input shape was 30, as I mentioned earlier. The number of feature was set to 1, which is just the closing value, which is what we were looking to predict. Just ran through all that right there. So we compiled a model using the mean squared error, MSE as the loss function. The optimizer is set to Atom, which is what we have been doing with all of our assignments this semester. The number of epochs was set to 25. This one took longer to run than the sine wave data, I guess just due to the nature of the data. So I didn't get to run a bunch of these. So here's the output, which is the loss. Here's the loss output of each epoch. And so there were 25 epochs. I just selected the every 5th epoch and then, averaged them. It was 3.448. You can see them up here. The 5th, 15th, and 20th performed best, which would be that one, and that one. The model performed worse on the 10th and 25th. Trained the model and tested all the testing data as per usual. As you can see, this model was not accurate. It did not turn out how I liked, and turned out similar to the Apple one from a previous assignment. As you can see, it's not catching any of the trends in the data. It's just a big, curved, smooth line. I guess it does predict that the price goes up when this price does go up a little bit, but obviously the values are leagues apart. It way overshoots what it believes the price is going to be. So it looks, I guess it just catches one of these little hills, and then it just thinks that's the rest of eternity and just continues to go upward at that same pace and never really realizes to come back down. Anyway, it did not perform very well, as you can see. So the part 5 was to redesign that model and run it again. And so there's a ton of things you can change. You can change the neurons, you can change the number of layers, you can change the dropout percentages, you can change whether the dropout layers at all, the number of epochs, the number of batches, the length, the sort length. There's so many different things you can change, which is overwhelming to me. Because if you change multiples of those, you don't really know, and you get a good result, you don't know which one of those that you change actually affected the model or improved the model. And so my kind of mindset is to just change one at a time. So I chose to reduce the number of neurons since I had success with that previously in the sine wave data, simple RNN. And so I reduced the number of neurons in the LSTM layer, first one, from 100 to 50. And then in the other 2 layers from 100 to 25. So a big reduction in the neurons. I left everything else the same, including the epochs, and ran it again. And so as you can see, the loss average was much better in this one, much better losses across the board. I could have just been, getting lucky on which epochs I picked. I would have to go back and look exactly at that. But I picked again every 5th out of 25. So here's the trained versus predicted. As you can see, it was also not great. In fact, it's almost like a mirror image of the other one, which I'll get to in a second when I talk about the comparisons. But anyway, it did not go well. It also did not catch any of the rises and falls. The only good thing I can say is that it caught a little bit of these first kind of downward trends right here, but it was never able to pull back up with, the market. And so it just kept going down. The stock actually went up over time, but the model predicted that it would go down. So this is kind of a overall, nothing really worked here, except the, except it going down right here. So for the comparison, part 6, like I said, I reduced the neurons. I only wanted to change one thing. The 2 models both had performance issues and neither one was a good fit. This one way overshot it. This one way undershot it. This one did get correct, that the closing price was trending upward. However, you could decide that with a coin 50, 50-50. It was not able to get any of the peaks or valleys in here in the data. I haven't succeeded in doing that in any of these LSTM assignments, so maybe I'm missing something, or maybe it's just supposed to be like that. I'm not sure, but that's disappointing. The only good thing over here, though, is, like I said, it was able to kind of catch these bottom trends right here pretty accurately for this first little bit. I mean, obviously it's not perfect, but I mean, probably when this happened, no one saw this much of a dip coming. So these little trends right there would be a good prediction, I guess. But after that, it just wasn't able to catch up. So I think if you were to further improve this model, what I would change would be the historic data points used, the number, and the size of the batches. So the historic data points used, I reduced it. I would really like to see an experiment and see what it would look like if you just put 300 data points in there. What would that model look like? I'm sure that would be overdoing it, and maybe it would look better with 100 or 60 again, or somewhere in that range. However, again, when we use 60 for the apple, I didn't get good results with that either. So I'm not sure that that would change it. Maybe adjust the batch sizes of the batches. Maybe that would also affect it. So I'm really curious as to how those would impact it most of all. Like we talked about earlier, there's a ton of things you could change to try to improve it. But those are the first two things, you know, I would work on. So part 7, you know, just kind of the summary of everything I've learned from the final project and also the previous assignment. So I think the most important thing I learned is that there's a lot of trial and error that goes into this. I'm not sure if that changes too much, you know, when you're making $300,000 as a data scientist at some big corporation somewhere. But I feel like all around there's a lot of trial and error. Everything I've kind of looked at online for improving, you know, the neural networks and stuff. And there's not really any definitive answers for a lot of it. A lot of it's kind of black box. They don't really know. If you look at like what's the good number of neurons to have, like it's all over the place. There's no definitive answer for a lot of these things. And so that leads to trial and error to kind of figure out what works for each particular model and each particular data set. And then two, I'm sure you're going to pick up strategies and tips and tricks, I guess, when you get more experience. Because I know this is kind of an introductory course for these, you know, these particular models. So I'm sure that does change a little bit over time. Definitely it would become very overwhelming, at least for me, if it was not done methodically. Because if you were to change several of the parameters, several of the inputs, and then your model significantly improved, I mean, I guess that's good, but you have no idea which one of those improved it. Maybe it was a combination of all of them, but you don't really know. Could have just been one of them. One of the things you done could have actually hurt the model and it could be better. So I think that really the only way to go about it is to kind of one by one try to isolate and see what's really affecting the model. I definitely have a large appreciation for data scientists and what they do. I mean, everyone knows it's a difficult job that you got to know a lot for, a lot of information for a lot of different subjects, ranging from statistics to math to programming to information technology. But I think it's I think there's a lot of kind of alchemy that goes in there and trying to really combining all these subjects, which is where I think the magic happens. And so just a new appreciation for that. I definitely learned a lot about recurrent neural networks this semester, and I thought it was really interesting, really learning the difference between the long short-term memory models and the just simple vanilla RNN models. And I feel like it gives a lot of insight into, you know, AI programs and stuff that Google, Facebook, and Apple and stuff are using for like voice recognition and text to speech and all kinds of stuff like that. So that's really cool. And most importantly, I feel like this class and these assignments have given me, you know, the confidence to tackle some of these design projects on my own in the future. You know, this class is about to end, but I feel like I could continue to experiment and really build some cool projects with what I've learned in this class in the semester. And so that's, I think, all I have. Yeah. So thank you guys so much for listening, and it's been a great semester.